Today, on how it's made. Yacht wheels. Aye, aye, Captain. Braided rugs. A twisted tail. Automobile thermostats. Keeping cool in the hood. And chisels. We chip away at the story. A wheel is a fairly modern way to steer a boat. Before the 18th century, captains shifted a stick attached directly to the rudder. Today, ship wheels connect to the rudder through a mechanical or hydraulic system. Found mostly in yachts up to 60 meters long, they're a luxurious way to echo the glory days of the sea. This company makes yacht wheels as large as 1.5 meters in diameter. It uses two traditional shipbuilding woods, American holly and Burmese teak, species that are as beautiful as they are durable. Workers use a table saw to cut both types of wood into long, thin strips that'll become the wheel's rim. They measure the strips with digital calipers, then sand them down to a thickness of just 3.1 millimeters. Using a disc sander now, a worker angles the ends into what are called scarf joints. He'll join the strips by fitting these angles together. After coating each strip with epoxy, he attaches it with clamps to a round jig, waxed beforehand to prevent sticking. The glue is waterproof because the wheels are often exposed to rough weather up on deck. The worker gradually bends each 2-meter-long strip all the way around the jig. And a spring-loaded clamp temporarily holds the end of each strip in place until he aligns the scarf joint with that of the next strip. It takes up to 8 hours of non-stop work to lay all the strips. He alternates between the blonde holly and the darker teak for a total of 7 layers. Then he leaves the rim to set overnight. To make each spoke, the wheel has 5 of them, a worker temporarily joins strips of holly and teak with double-sided tape. A computer-guided cutting machine then carves an opening through the middle and shapes the outer edge into a triangular shape. This reduces the spoke's weight and helps it fit to the rim later on. Next, he removes the tape and glues the wood strips together, along with others made of carbon fiber. They strengthen the spoke while keeping it lightweight. He places a waxed jig in the center and clamps it in place. He leaves the spoke to set overnight. The next, he sands away the dried glue, then uses a router to round the edges. Together, the 4 wood and 3 carbon fiber layers are just 2.5 centimeters thick. He traces a template on a stack of 14 pre-glued curved strips of holly and teak. He follows his trace lines with a bandsaw, cutting out what's called a fairing. This component will join each spoke to the rim. Now he drills a hole in each fairing and inserts a temporary dowel to position a reinforcing strip of carbon fiber at the top. It's time to join the spokes to the rim. Earlier, he glued strong fiberglass dowels to the rim. Now he inserts them into the fairings and into holes in the spokes, also glued beforehand. Through the openings, he clamps the spokes to the rim. Then he positions an aluminum hub in the center, tapping it into place with a mallet. Now with a jigsaw, he cuts a sliver off the ends of the fairings so they'll curve into the rim. He uses a router to round off the vertical edges of the wheel. He files the fairings by hand to complete the smooth transition to the rim. Just these finishing touches alone can take up to 5 hours to complete. Using a router, it takes him another 5 hours to gradually round off the horizontal edge. Now to protect the wheel from the elements, particularly sun damage. First, a polyester primer. Then they sand it and apply 2 coats of waterproof varnish. On the yacht, 5 stainless steel bolts attach the wheel to a pedestal that connects to the rest of the steering mechanism. To change how fast the rudder moves, you simply turn a knob at the center of the wheel. How's that for power steering? To get you where you're going, come hell or high water. New England settlers in the 1700s were the first to braid strips of used clothing and then sew them into rugs. Today, high-speed machines create this classic look in a fraction of the time, but with synthetic as well as natural fabrics and yarns, the rugs last even longer. This company's most popular rugs are oval or rectangular, some small enough for your stairs. The rugs begin as yarn. They wind the yarn onto bobbins that fit the factory's machines. The yarn ranges from pure wool to a blend of wool and polypropylene that makes the rug durable even outdoors. This machine braids yarn from 24 bobbins around a core of synthetic fabric. The result is a complicated weave called cable lock. Other rugs have just 3 braided segments in what's called a flat braid. Here, a worker uses a powerful sewing machine to join flat braids with sturdy nylon thread. This makes one enormous piece the length of half a tennis court. The piece moves along a conveyor to an automated rotary saw that cuts it to size. The saw passes twice to ensure a clean cut through the 2.5 centimeter thickness. Another industrial sewing machine attaches binding tape to seal the edge. This prevents rectangular and square rugs from unraveling. Oval and round rugs don't need this because their braids aren't cut. This machine does what's called serging. It sews yarn over the binding tape to cover it, a purely aesthetic gesture. To make fabric rugs, a seamstress joins several pieces of different fabric along one edge. They're a cotton and polyester blend that's durable and easy to wash. The more patterns, the zanier the rug will look. After they wind the fabric into a roll, a rotary saw cuts the roll to make strips that are 2.5 centimeters wide. The fabric strip then unwinds into a machine that folds it over filler. This forms the core of the fabric tubes they call spaghetti. The machine wraps the fabric around the filler, then sews the edges into a closed tube. Rollers guide the spaghetti out of the machine and onto bobbins. This machine weaves spaghetti from 3 bobbins into a flat braid. Fabric rugs are made only as flat braids because the material is too thick to weave into a cable lock. The braids settle into barrels for storage until they're woven into rugs. Sometimes, mats are assembled from a variety of braids for a different look. To make an oval or round rug, a worker coils one continuous braid around itself. At the same time, she sews each braid to the next. These rugs can have anywhere from 16 to 320 rows. This factory uses tables with holes that blow pressurized air to float rugs like this one as they grow heavier. The ovals range in size. They can be as small as a doormat and as large as a swimming pool. when the rugs get really big, some extra help may be required. It takes her about 2 hours to sew together one of these huge rugs. Lastly, a worker staples a tag to the rug that reveals the style and size before the rug heads off to shipping. Perhaps more than any other floor covering, these rugs don't just lie there. The variety of styles and shapes means they really tell a story at your feet. Only about 5 centimeters in diameter, a car's thermostat sits between the engine and the radiator. Until the engine warms up, it blocks the flow of coolant to the radiator. When the engine reaches about 95 degrees Celsius, the thermostat opens, letting coolant flow through the radiator and into the engine to prevent overheating. The key component inside the thermostat is wax. When the engine heats up, the wax melts and the thermostat opens, triggering the cooling system. The wax melts quickly because it contains powdered copper, graphite, and/or aluminum. As the wax transforms from solid to liquid, it expands. The pressure pushes a pin that opens the valve that enables the flow of coolant to the engine. After heating and mixing in the powders, workers pour the wax into slab-shaped molds. It takes about a half hour to cool and solidify. Then they extract the slabs and grind them up. They feed the granulated wax to a pill-making machine, the kind pharmaceutical factories use. It compresses the granules into cylindrical pellets. Meanwhile, workers feed a copper strip into a machine called a high-speed transfer press. Its successive stations shape the copper cup that'll house the wax pellet. The first station stamps out a circle. The others progressively stretch and form the circle into a cup. The cups go into an automated assembly machine, which drops a pellet into each one. A pin then bores a hole down the center of each wax pellet. The machine inserts a rubber sleeve into the pellet hole and caps the sleeve with a brass cover. Then it crimps the cup over the cover, forming a seal that's leak resistant. Now the machine inserts the stainless steel pin that opens and closes the coolant flow valve. The pin goes right into the rubber sleeve in the center of the wax pellet. How do all these parts work together? The melting wax expands within the cup, squeezing the rubber sleeve. That forces the pin upward, opening the coolant valve. Now they heat the parts to the temperature at which engine cooling should kick in. The calibration machine squeezes the cup until the pin rises enough to open the coolant valve. The components now enter a machine which connects that valve. The valve is made up of 2 stainless steel pieces. The machine loads one on top of the other over the thin end of the cup, then pushes the valve over the end of the cup, attaching it to the wide end. On the left is before the valve installation, and here's after. Meanwhile, a press forms the top part of the thermostat, called a flange. It's made of stainless steel coated with a lubricant. As with the cup, a series of dies progressively forms the flange. Now for the final assembly. First, the thermostat's stainless steel frame. Next, a stainless steel spring. Its job is to close the valve when the engine cools. Now the assembled components go inside the spring. The flange goes on top. A tool called an orbital riveter flattens a tab on either side of the flange. This holds the frame onto the flange. The assembly machine now crimps 2 little tabs against the pin, keeping it from falling out of the rubber sleeve. And with that, the thermostat is finished. This demonstration shows how the melting wax pushes the pin upward. And when the engine cools, the opposite happens. So that even though you might boil over in heavy traffic, your engine doesn't have to. A chisel is a metal tool with a sharp end for shaping stone, metal, or wood. You use your hand, a hammer, or a mallet to drive it in and cut. Although chisels date back to ancient Asia, today's factories use heat-treated steel and high-tech machines to make them stay sharper, longer. A wood chisel needs to be very sharp, especially for intricate carving. Making chisels starts when they insert a 5-meter-long bar of high-carbon steel in a mechanical press. The carbon lets them heat-treat the steel to give it a long-lasting edge. But first, the press cuts the bar into 22-centimeter-long rods. The rods then go through an induction heater. In just 6 seconds, a magnetic field heats them up to about 1300 degrees Celsius, a temperature at which the steel can be forged. A worker sets each hot rod into a die in a forging press. The die slams down, applying 700 tons of pressure. This produces what's called a forging, a rough shaping. The die can produce as many as 60,000 forgings before it wears out. Each one goes into what's called a trimming press. Here, a die cuts out the precise shape of the chisel, with the blade on one end and the tang on the other. The tang later fits into a plastic or wooden handle so you can comfortably grip the tool. The factory sends the excess metal out for recycling. After the chisels cool off for several hours, workers run them through another induction heating machine, this one with 2 coils. The first heats them to 760 degrees Celsius. Then warm water cools them down. This rapid reduction in temperature is called quenching. It's what hardens the chisels enough to be strong and stay sharp. The next coil heats them to about 370 degrees Celsius. This step is called tempering. It relieves the stresses that the quenching phase created inside the metal. Spring-loaded clamps now release the chisels from the machine, and they drop into a container to cool overnight. The next day, workers can start to polish and sharpen the chisels. That removes the metal discoloration the heat treating caused. To polish the barrels, the round area joining the blade and the tang, workers load the chisels into devices called chucks. These clamp the chisels securely by the blade as the barrels spin against a rough grit sanding wheel. After about 7 seconds of sanding, the blades are ready for polishing. A powerful magnet locks them in place on a round table. It rotates, running the blades against an abrasive grinding wheel. As water cools the metal, it also applies a rust-proofing chemical to the steel. This polishing cycle takes about 20 seconds. The highly polished finish is a key selling point. Now, to sharpen the blades, a worker loads the chisels into another machine. It moves the chisels back and forth against another grinding wheel. After about 5 minutes of this, the blades are razor sharp. Only the last centimeter of the chisel, sloping at a 22-degree angle, is the cutting edge. This factory uses pre-formed extruded plastic handles for its chisels. A hot metal die with raised lettering presses and melts a colored plastic ribbon into each handle. This imprints the company logo, the model size, and a reminder to wear safety goggles. The next machine puts a steel cap on top and forces the tang inside the hole. The cap reinforces the handle against hammer blows. The tang stays put because it's actually a bit bigger than the hole it goes into. In industry lingo, an interference fit. The finished tools come off the line. Now you can have those chiseled features you always wanted.